Hello children, see in this video I am going to discuss most important concepts. A NEET aspirant must know questions from the chapter Motion in a Straight Line. See, the first question is position time graph of a uniformly accelerated body. See, position time graph of a uniformly accelerated body will be a parabola. Okay, now see this one. Here the acceleration is positive. Okay, acceleration is constant and it is positive. Okay, now see, the parabola can be like this also. Here the acceleration is less than 0 or negative. Okay, and if the body is moving with a constant velocity, means the acceleration is 0, then the position time graph will be a straight line inclined to the time axis. Okay, this is positive acceleration and it is constant. Okay, this is negative acceleration, it is also constant. Both these are parabola. Okay, and here the acceleration is 0 or the body is moving with a constant velocity. Now let's see what we have next. See, a train 100 meter long is moving with a constant velocity of 45 km per hour. Time taken to cross a bridge 1 km long. Okay, now see, here we have a bridge and this is 1 kilometer, okay, and we have a train and its length is 100 meter. See, train length is 100 meter means this is actually, see, 100 means must be in kilometer, it is 0.1 kilometer. Okay, suppose the train is coming from that direction. Okay, now see, we can say that train started to cross the bridge when its position is like this. This is the front end of the train and this is the back end of the train, and the train is moving like this. So when the train reaches here, we can say that it started to cross the bridge. Okay, now see, suppose the front end of the train is at the end of the bridge. Now see, it has not completed the crossing of the bridge. Okay, we cannot say that this train has crossed the bridge at this position. Okay, now see, we can say that it is crossed the bridge only when it reaches a position like this. Okay, this is the front end of the train and this is the back end of the train. Okay, now here the train is moving with a constant speed and we have to find the time taken by the train to cover a particular distance and how much is that distance. Let's consider the front end of the train. Crossing the bridge means the front end of the train has to move from this position to this position. And what is the distance? Okay, see, from here to here it is 1 kilometer and this is the length of the train and it is 0.1 kilometer. So the total distance the train has to cover, that is 1.1 kilometer. Okay, and we want to find the time taken by the train to travel this much distance. Okay, now see, we have the formula T, time equals distance divided by speed, if the speed is constant. Okay, here we have this distance is equal to 1.1 kilometer and speed we have 45 kilometer per hour. If the distance is in kilometer and speed in kilometer per hour, we will get the time in hours. So the time taken by the train to cross the bridge is this much hour. But we have the, see, time in seconds. Okay, see, if you multiply this by 60, you will get the time in minutes. Okay, and if you multiply with another 60, you will get the time in seconds. Right? Now this 45 and this 60. Okay, we can divide both by 15. Okay, so here you will get 3 and here you will get 4. Okay, now this 3 and 60. Okay, here you will get 20. Right? 20 into 4, that is 80. 80 into 1.1. 80 into 1.1 means 8 into 11. Okay, so you will get 88 seconds. Okay, so the answer is 88 seconds. Now let's see the next question. A freely falling body has a velocity vector, it falls the velocity v after it falls through h. The further distance it has to fall down for its velocity to double is. See, I am following only a conventional method. I am not applying any shortcut or quicker methods. Okay, conventional. Anyone can easily understand, follow. Okay, now C has a velocity v after it falls through h. Further distance it has to fall down for its velocity to double. Okay, see here the velocity is 0, and see when it falls through a distance h, it acquires a velocity v. Okay, what additional distance it will have to travel so as to get its velocity doubled? Okay, means a velocity here it must be 2v, right? 2v. Okay, now see here we have this v square. This is equal to u square plus 2as, and see v square minus u square. Okay, this is equal to 2as, and yes, you will get see v square minus u square divided by 2a, right? Okay, now see, let me keep this here. Okay, now see from here to here, when you apply this, see this formula. Okay, see yes, displacement it is h equal to final velocity is v square minus initial velocity 0 square divided by 2, acceleration here it is g. Okay, and from and from here to here, that we have to determine. Okay, see, say it is h dash, this is equal to, what is the final velocity? That is 2v. Okay, so 2v whole square minus v square divided by 2g. 2v whole square, that is 4v square, minus v square. This is actually 4v square minus v square, this is 3v square. Okay, divided by 2g. Right? Now see here we have, see this is actually v square divided by 2g. Okay, that is h. Now see, this much is h. So we will get this is equal to 3h. So when it falls through a distance h, it gains a speed v. Okay, what further distance it will have to travel so as to get its velocity doubled? Okay, this will be 3h. This is 3h. Okay, so this must be the correct option. Now let's see what we have next. A car traveling at 80 km per hour is slowed down to 44 km per hour in 15 seconds. Okay, the retardation is, okay, now see we have v equals u plus at, and what is a? It is the acceleration. Okay, now acceleration, or see when you take that u to the left, you will get v minus u. This is equal to at. Okay, and acceleration, this is equal to v minus u divided by t, v minus u by t, right? And see here the final velocity is 44 km per hour. Initial velocity is 80 km per hour, and time, see this is in kilometer per hour. Okay, and time is 15 seconds. So this will give you acceleration, but we have to find the retardation. Retardation is negative of acceleration. Okay, now see acceleration a, we will get, see this is equal to, see 44 minus 80, that is actually minus 36. Okay, minus 36 kilometer per hour, and in the denominator we have 15 seconds. So as this see answers are given, options are given in meter per second square, so we have to convert this kilometer per hour to meter per second. Okay, Now see, how do you convert this 36? In order to convert this 36 into 5 divided by 18, 5 by 18. Okay, 36 kilometer per hour. Okay, and this you will get, this is equal to 10 meter second raised to minus 1. Okay, 10 meter second raised to minus 1. So here you will get, this is, okay, minus 10 divided by 10 meter second raised to minus 1 divided by 15 seconds. Okay, so this is actually, it is minus 2 by 3, right? This is minus 2 by 3 meter second raised to minus 2. That is acceleration. We have to get retardation. Retardation is negative of acceleration. Okay, so retardation is negative of acceleration, means 2 by 3. Okay, meter second raised to minus 2. Okay, 2 by 3 is 0.6666, like that. So when you round off it to two significant digits, you will get 0.67 meter second raised to minus 2. Okay. Now let's see next question. A particle starts from rest and moves with constant acceleration. It covers a distance s1 in the first 10 seconds and a distance s2 in the next 10 seconds. Okay. Now see, when a body moves with a constant acceleration, its velocity changes equally in equal time. Okay. Now see, this is the line along which the body is moving. Okay, now it starts from rest, initial velocity u equal to 0. Okay, in first, when a body starts from rest and moves with a constant acceleration, its velocity changes equally in equal time. And suppose the velocity here is v and the time required is t. Means in first t seconds, its velocity is increased by v. In next t seconds also, its velocity will increase by the same amount. Okay, v means it becomes 2v. Okay, in the next interval, in another t, its velocity will become 3v. Okay, now after one more t, its velocity will again increase by v. Okay, time required will be again t. Okay, now see, the ratio of displacements will be, if the displacement here is s, here it will be 3s, here it will be 5s. Okay, here it will be 7s, like that. It will be in the ratio of odd numbers. Okay, now see, this t can be any equal interval. Here it is given that all these are 10 seconds. Okay, so this can be first 10 seconds, next 10 seconds, next 10 seconds, like that. It can be any equal interval. Okay, now see this, see S1, this is S1, here we have S1 equal to S. And displacement in the next interval S2 we have 3s. Okay, or let us say S2 equal to 3s1. Okay, so S2 equal to 3s1. Right, now how do you get this one s and this one 3s, this one 5s? How do you get that? See, displacement s equal to v average into time. See, this is unconditional. It is always true. V average multiplied by time will give you the displacement unconditionally. Then in order to find the displacement, you have to get the average velocity. How do you find the average velocity? See, there is a simple formula to find the average velocity. That is, see, V average, this is equal to initial velocity plus final velocity divided by 2. Or we can say the arithmetic mean of initial and final. Children, here we have a condition. This can be used only when the acceleration is constant. This is unconditional. Anywhere or everywhere you can use that formula. But average velocity is the arithmetic mean of initial and final only when the acceleration is constant. That acceleration can be positive or negative. Only thing is that it should be constant. Luckily, here we have constant acceleration. Okay. When you consider from here to here, initial velocity 0, final v, average will be 0 plus v by 2, means v by 2 into t. So this displacement s is, this displacement s, okay, this displacement s, okay, this is actually, see, this is vt, okay, this is v by 2 average velocity into t, right? And when you consider this segments, okay, what is the initial velocity? Okay, what is the initial velocity? See, here the initial velocity is v and final velocity is 2v. So average will be v plus 2v by 2 whole divided by 2. So v plus 2v, 3v by 2 into what is the time t. So here the displacement will be 3v by 2 into t, 3v by 2 into t. Now see, v by 2 into t is s, and here this v by 2 into t, that can be replaced by s. So we will get 3s, okay, 3s we will get, right? And here initially is 2v, final is 3v. Average will be 2v plus 3v whole by 2. That is 5v by 2 into time, 5vt by 2. So here the displacement will be 5v by 2 into t. Okay, again this vt by 2 can be replaced by s because s is vt by 2. So here we will get see 5s, right? Okay, so that is very simple. S2 will be equal to 3s1. Now see, we have another wonderful question. A stone falls from the top of a tower in 8 seconds. Time taken to cover first quarter of the distance is. Okay, now see, a stone falls freely, okay, initial velocity here it is u equal to 0, okay, and total time let it be capital T, okay, and the height that is h, okay, from here to the bottom time taken is capital T and the distance through which it falls, that is the height of the tower, it is small h. Now the question is, see, suppose this much is h divided by 4, okay, and from the top to this distance h by 4, suppose the time taken is small t. If capital T, the total time of fall is 8 seconds, what is this small t? That is the time required to cover first quarter. Okay, now see, initial velocity is 0. Let us apply the equation s is equal to ut plus half a t square, at square, okay. As it falls freely under gravity, acceleration is equal to acceleration due to gravity, and the initial velocity here it is 0. So when you consider the motion from the top to the bottom, okay, the entire motion, okay, so the displacement is h, initial velocity u0, so ut, this term will vanish, okay, then half acceleration is g and time, okay, time, the total time is capital T, okay, so g capital T square. See, displacement is a vector, acceleration is also a vector. See, displacement is always from the initial to the final. So here we are, this is the initial position at the top of the tower and this is the final position at the bottom of the tower. So displacement is from the top to the bottom. From the top to the bottom, displacement is directed downwards. And what about acceleration? Acceleration is that due to gravity, the attraction of the earth. It is also directed vertically down irrespective of the direction of motion of the body. Acceleration due to gravity downward, displacement downward. Let me take downward direction positive. So this I have taken positive, this I have taken positive. Okay. Now consider the motion from here up to this point where the displacement is only h by 4 and the required time is small t. Okay, so here is h by 4. This is equal to half, acceleration is g and time is small t square. Let me divide these two. See, h divided by h by 4. Okay, that you will get 4 equal to, here we have half g and here also half g. So both will get cancelled. So you will get t square divided by small t square. Okay. Or let us say 4 is actually 2 square. This is equal to capital T by small t whole square. Right. See, both sides we have perfect square. So you will get t divided by small t. This is equal to 2. Okay. So small t, this is equal to t divided by 2. Okay. T, the total time is given as h divided by 2. So this is 4 seconds. Okay. So the time required to cover first quarter of the total distance, that is 4 seconds. Okay. Means see, half of the time is taken to cover the first quarter, right? Now let's see what we have next. See, a boy is throwing balls into air, throwing one when previous one is at its highest point. How high do the balls rise if he throws once in a second? Now see, he throws once in a second, means in every 1 second he throws one ball. Means he throws one ball, after 1 second he will throw the next ball. He throws one ball, when it reaches the maximum height, he throws the next ball. After 1 second, he throws the next ball. What does it mean? See, the ball thrown will reach the maximum height after 1 second. Okay. See, each ball reaches the maximum height after 1 second. So, at the highest point, velocity v equal to 0. Initial velocity that we do not know. See, let me apply this equation v equals u plus at. Okay, at the highest points, see, each ball reaches the highest point after 1 second, where its velocity becomes 0. Okay, initial velocity we do not know, u. Okay, u is directed upwards, that I have taken positive because I have written plus u. Okay, acceleration is that due to gravity, it is directed down. See, if I have chosen this upward initial velocity as positive, then downward acceleration due to gravity must be negative. Okay, and the time after which the body reaches the maximum height is 1 second. Okay, that is 1 second. 1. Okay, so here you will get u equal to, see, the value of g. U equal to the value of g. What is the value of g? It is actually 9.8. Okay, so see, each ball is thrown vertically up with a velocity equal to 9.8 meter per second. Okay, now see, how high do these balls rise if they are thrown with an initial velocity equal in magnitude to that of the acceleration due to gravity. We have to find the maximum height attained by each ball. See, at the high, let me apply this equation v square equal to u square plus 2as. See, at the highest point, velocity again becomes 0. Initial velocity is directed up. That, let me take it positive, so u square. Okay, plus 2as. See, acceleration due to gravity. Acceleration due to gravity is directed vertically down. So a is downwards. Body is thrown upwards. Okay, so see, body starts from here and it goes like this. Okay, so this is the initial position and this is the final position. Displacement is always from the initial to the final. Okay, so displacement here, it is equal to h and it is directed upwards. And acceleration a, this is equal to g and it is directed downwards. So as, one is upwards and the other is downwards. So one will be positive and the other will be negative. So the product will be definitely negative. So here it will be 2. As we can write GH. Okay, GH. Where H is the maximum height. Now let me take this minus 2GH to the left. So I'll get 2GH. This is equal to U square. And H equals U square divided by 2G. Okay. Now the initial velocity is equal to the value of acceleration due to gravity. Okay, so this is g square divided by 2g. Okay, you can cancel one g from the numerator and denominator. So the maximum height will be equal to half the value of acceleration due to gravity. Acceleration due to gravity is 9.8. So its half will be, so h you will get 4.9 meter. Okay, 4.9 meter, this one. Now see, we have another important question. A stone thrown up with a speed u from the top of a tower reaches the ground with a speed 3u, then the height of the tower is, okay. Now here we have the tower, okay, and let the height of the tower is h. Initially the body is thrown with a velocity u, okay, so it is directed vertically upward, okay. The body will be going like this, okay, and see, ultimately it reaches the bottom, okay. Now see, the final velocity, that is equal to 3u, and it is directed downwards, okay, irrespective of the direction of motion. Acceleration due to gravity is always downwards, okay. Here we have initial velocity u, this is directed upwards, final velocity v, that is equal to 3u, and it is directed downwards, okay. Acceleration a equal to g, it is again directed downwards. What about the displacement? See, in case of displacement, you should not consider the path followed. Displacement is simply from initial to final. See, body started from here and ultimately it reaches at the bottom. So the displacement will be from the initial to the final, means from the top to the bottom, okay. So displacements, yes, this is equal to h, okay, downwards. Now let's apply this equation. V square equals u square plus 2as. Now see, we have initial velocity u, that is directed vertically upwards, final velocity 3u, that is directed vertically downwards, acceleration downwards, displacement downwards. So we have three quantities directed down and one quantity directed up. Any of these directions, upward or downward, you can choose as positive. Only thing is that opposite should be negative. Okay, now here let me take, I have three quantities directed downward, so let me take downward direction positive in here. So final velocity is equal to 3u and it is directed downwards. I am taking it as positive, so this v is equal to 3u, okay, whole square, and this is equal to, initial velocity is directed upward, it should be taken as negative, okay, so minus u, okay, whole square, then plus. See, both the acceleration and displacement are directed down, both are positive, so the see, product will be positive, 2g, and the displacement is the height of the tower, h. Okay, 3u whole square, we will get 9u square, okay, and on the right side minus u whole square means it is u square, then 2gh, okay. Now see, when you take this u square to the left, it will become a 9u square minus u square, or you can write 8u square, this is equal to 2gh, and h you will get 2 and 8 can be, see, 8 by 2, that will be 4, so on the right side we will get 4u square divided by g, that is the height, okay. So this is 4u square by g. Now let's see what we have next. See, a car is moving with a uniform acceleration along a straight line PQR. Its speeds at P and R are 5 meter per second and 25 meter per second respectively. If PQ is to QR is in the ratio 1:2, then the ratio of the time taken by the car to cover the distance PQ is to QR is. Okay. Now let's see. See, this is P and this point is Q and this point is R. Okay. And here the velocity, this is, say this is U, and this velocity is V1, and this velocity is V, okay, final velocity, right, that's V. Now see, throughout the motion acceleration is constant, okay, and see the displacement R, see PQ is to QR is in the ratio 1:2, means QR is twice the distance PQ. So if this is S, this will be 2S, okay, 2S. Now see, consider this equation, V square. See, V square equals U square plus 2AS. V square equal to U square plus 2as. And see, you can write V square minus U square equal to 2as. Okay. And what would be the expression for acceleration? Acceleration, we will get A. See, this is V square minus U square divided by 2s. Children, this is not the shortest possible method. See, this is conventional method. And I am explaining conventional method only because, see, all of you should understand. Okay. Now, see, this is the expression for acceleration. See, acceleration is constant throughout the motion. So, if you find the acceleration from P to Q and from Q to R, you will get the same. See, the acceleration should be the same. Okay. Now, see, this is the acceleration. Final velocity square minus initial velocity square whole divided by 2s. Okay. Now, first consider the motion from P to Q. What is the final velocity? That is V1. Okay. V1 square minus initial velocity is U square. Okay. Divided by 2, displacement is S. Okay. And now consider the motion from Q to R. Q to R. When you consider the motion from Q to R, initial velocity is V1 and final velocity is V. Okay. So, here V square minus V1 square divided by 2, displacement is 2s. Displacement is 2s. This is the expression for acceleration from P to Q, and this is the expression for acceleration from Q to R. Body experiences the same acceleration throughout. Means these two must be equal. These two must be equal. Okay. Now see, here you have a 2s and here you have 2s. These 2s on both sides can be cancelled. Okay. Now this 2 can be taken to the left. So you will get 2, then V1 square minus U square. Okay. This is equal to V square minus V1 square. Right. Okay, now see, let me keep this here, okay, and this one here, okay. So we have got this one here, right. Now let me open this bracket, see 2v1 square, right. So 2v1 square minus 2v1 square minus 2u square, right, minus 2u square. Okay, this is equal to V square minus V1 square. Okay. Now, see, take this minus V1 square to the left. It becomes plus V1 square. Already there is a 2V1 square. Okay, when this plus V1 square also comes, it becomes 3V1 square. Okay, and this is equal to, when this minus 2U square is taken to the right, it becomes plus 2U square. Okay, and already there is one V square. Okay. Now see, let me take this here. Okay. Now, okay, this can be kept here. Okay, this is here and this one. Okay, this one here. Right. So we have expression 3v1 square. V1 is the velocity at the point Q. Okay, that is 2u square plus v square. And u, see, u velocity at the point P, it is given as 5 meter second raised to minus 1. And v, this is given as 25 meter second raised to minus 1. See, I am going to find v1. Okay, here we have, see, 3v1 square. 3v1 square equals 2 into u square means 5 square, okay, plus 25 square. Okay, that is v square. V is 25. And here, see, 5 square is 25 into 2, that is 50. Okay, plus 25 square is 625. Okay, and this is equal to 675. Okay, that is 3v1 square. Okay, this is 3v1 square. Okay, so v1 square will be 675 divided by 3. So v1 square, this is equal to 675 divided by 3, and this is equal to 225. 225 is a perfect square. What is the square root of 225? It is 15. So we will get V1 equal to 15 meter second raised to minus 1. See, what do you understand by constant acceleration? Velocity changes equally in equal intervals of time. See, here we have got the velocity V1. V1 we have got 15 meter second raised to minus 1. 15 meter second raised to minus 1. So as the body moves from P to Q, velocity increases by 10 meter per second. When it moves from Q to R, velocity again increases by another 10 meter per second. Okay. See, as the body moves with a constant acceleration, time required for equal change in velocity will be equal. See, whatever time is taken by the body to increase its velocity from 5 to 15 means by 10 meter per second. Same time will be required to increase from 15 to 25 also. So this time taken by the body to move from P to Q and Q to R will be equal. So the ratio will be 1:1. Okay. Now let's see the next question. A person travels along a straight road for the first half distance with a velocity v1 and for the second half distance with a velocity v2. Then the mean velocity, see here the total distance is divided into two equal parts. So the average speed is actually the harmonic mean. So here you can write 2 by v average. This is equal to 1 by v1 plus 1 by v2. Okay, and so you will get v average. This is equal to 2 v1 v2 divided by v1 plus v2, right? Now see, suppose the total distance is divided into three equal intervals. Okay, here distance is divided. Okay, if it is divided into three equal intervals, means first 1/3 of the distance is covered with a constant speed v1, second 1/3 with a constant speed v2, and see last 1/3 with a constant speed v3. Then the average speed is given by 3 by v average. This is equal to 1 by v1. Okay, 1 by v2 plus 1 by v3, right? But here it is divided into two equal parts only, so the average speed will be this one, 2 v1 v2 over v1 plus v2. See children, these are very important questions and you should understand all these questions very well. Okay, thank you.